welcome to this Nordic Tech webinar, introducing the Thingy:91X, the ultimate cellular IoT prototyping platform. And today's host, that's me, Martin Lessund. I am a technical product manager for Cellular IoT, and I've been working at Nordic for almost 8 years now. I started off in a technical support group and then moved over to product management. My focus has almost been all the time around cellular IoT. So, some practicalities for this webinar. It's around 35 minutes, and then we will have a Q&A at the end. So questions are encouraged. Just type the questions at the top of the right sidebar. And questions are anonymous, but try to keep them relevant to today's topic, which is around the overview of Thingy:91X. The chat, however, is at the bottom. That's not anonymous. And if you have any questions after this webinar, you can go to DevZone, where we will answer all your questions. And a recording will also be available, as well as the slides at Nordic Semi, webinars.nordicsemi.com. And we always strive to excite and support developers using our products and solutions. So we deliver webinars such as this, where we go into technology and also around products and some trainings. And we have DevZone, of course, which is our technical support forum, as well as an online community. And Tech Docs, that's a single source for all of our technical documentation. And then, last but not least, we have Dev Academy, which is an interactive online learning platform where we have NRF Connect SDK fundamentals, Cellular IoT fundamentals, and so on. So that's a very good starting point if you want to learn about the technology and how to use it and apply it with our products. And short on the agenda today, we will have an overview of the product, the Thingy:91X, and then a demo. And then comparing the old Thingy:91 versus this new Thingy:91X, some hardware features, software ecosystem, and then the reference design topic at the end. And of course, a Q&A at the very end. So, overview. What is the Thingy:91X? Well, it's a prototyping platform. So this device is very useful for a developer or someone that wants to make a quick prototype without designing and producing their own custom device of some kind. They can just use this hardware, as it includes a lot of components, which gives you wireless communication such as LTE-M, NB-IoT. It also has GPS support, NR+, and with the addition of other chips we have for Bluetooth Low Energy and also Wi-Fi, you can get a lot of functionality with this kit. The main focus is cellular IoT, however, it can be used for other stuff as well. And it includes a lot of sensors. So you have environmental sensors, accelerometers, etc. So you can make a lot of different prototypes with this device without needing to hook up other stuff. But we also have the opportunity to do that. We have now, with this new device, added support for expansions via connectors that support this QWIIC standard and also this Stemma QT. So you can connect any peripherals or other stuff that you want to communicate with this device. So there's a lot of things you can do with it, and it also is a good playground to learn about our devices and how to make things work. And we have made, in my opinion, the quickest and easiest way to get started with cellular IoT with this out-of-box experience that I will show in the demo quite soon. And also in the box we included 2 pre-registered SIM cards, both from Wireless Logic and Onomondo. And we have also integrated the cloud directly with this device, so it will communicate with our optimized NRF cloud, and the firmware is of course from our NRF Connect SDK. Now let's go over to the demo on how you set this device up.
This is the Thingy:91X prototyping platform. Let's take a look what's inside of this box. So when you get your kit, you can actually see inside here you have a welcome card, 2 SIM cards, one from Onomondo and one from Wireless Logic, as well as the Thingy 91X and a expansion board you can use to do current measurements, debugging, as well as some GPIOs available here. So when you open the kit, you can take a look on this welcome card. First you plug in your SIM card, turn it on, and then you scan the QR code which is on the sticker. So let's do that. So when you have the camera up, you can either scan the QR which is on the sticker or follow the URL which is on the link there. And here you can see it, your device is working perfectly. I'm connected to LTE-M and you have 9 degrees Celsius and excellent air quality since I'm outside. And I can also interact with my device. I can press the button on the device and I can see, okay, button pressed. 2 seconds ago, 5 seconds ago. You can also change the LED color. If I click the LED on the left hand side, I can switch it to red. And then I can click the button again to update it. And you can see it's now red. Now I want to change it back to what it had earlier. And if you are wondering what the LED is showing, you can click on the LED patterns, showing what it's doing, connecting to LTE network, cloud communication, searching for location, or red if there's some error. Okay, since I'm outside now, you can actually see the cell-based location of my device. And you can see the big circle or hexagon is the single cell, so that's using 1 base station. And the smaller one with 452 meters of accuracy is multi-cell, so that's using several base stations. And if you look closest, you can see the GPS, and that has an accuracy of 12 meters. So that's the area where I'm located. Since there's no Wi-Fi access points in this area, you are not seeing Wi-Fi location. And here's also some information of what the different location services do and how they work. All this is, of course, powered by NRF Cloud services. You can also see the history of the state of charge. So when this is used, you can see the state of charge is going down. And we get the fuel gauging from the NPM 1300, which is on the kit. And here we also have some additional information on the firmware used, and also some abilities to change the configuration of the device. So basically you can turn on the real-time mode, low power mode, enable, disable the GPS, and then apply. You can also read on the included SIMs, and at the bottom you see what's next. And that's open up quick start for switching the firmware, or then you can read the documentation. So now let's have a use case. I'm going to put this prototyping platform inside my backpack and then take a walk around this lake, and then we can see the results on the web page afterwards. So now the Thingy91X is tracking each minute the GPS position and then sending that to the cloud using LTE-M. So as you can see, it started raining, so I'll end the demo here, but if you look at the map, the tracing is around the lake quite nicely. So my backpack is tracked and I have it safely here. So now I am at a more urban area where there's houses around. And now the Thingy91X picks up the Wi-Fi access points and sends this information to NRF Cloud, and then gather this information to give an accurate estimate of the device location. So this is a perfect combination of low power and high accuracy using Wi-Fi location. It also works inside and outside. So compared to GPS, which only works inside. That's the benefit with Wi-Fi.
That was the demo on out-of-box experience with the Thingy:91X. And just to explain a bit around the firmware that's running out of the box, we have it listed here. It basically talks to NRF Cloud through an optimized co-op protocol. So that's UDP based, meaning it will work very good both on LTE-M and NB-IoT. It's also much more power efficient compared to TCP based protocols such as HTTP or MQTT. So we have tried to make it a very low power optimized firmware, this out-of-box firmware, and that's why we chose co-op. And that communicates, of course, with our cloud solution, NRF Cloud, and then uses REST APIs to urge this dashboard that is showcased on the right-hand side. So the neat thing with this device here, every device has a unique URL or a fingerprint and also a unique QR code pointing to this URL. So you can go directly to your web page and look at your device and basically sanity check what's going on with this device. Is it communicating? What's the battery temperature? And then you can do some simple prototyping just with this out-of-box firmware. And here are also listed the firmware documentation and the GitHub links to both the firmware on the device but also on the dashboard. So you can use that as reference if you want to build your own dashboard or firmware based on this. So what's actually the next steps after you have done this out-of-box experience? Well, we have a desktop program called NRF Connect for desktop. And inside there we have an app called Quick Start. So let's take a look on that now. So here you can see I've opened up the NRF Connect for desktop, and inside here we have Quick Start. Get started with the new Nordic Semiconductor device. So I open it, plug in the Thingy:91X and turn it on, and it will automatically pop up. So at the left hand side you can kind of see the journey that Quick Start will guide you through. And first up, just some information about the device, so you can read about this, also links to the documentation and also some recommendations. And the next thing, you can give the name of the device, so that will be stored and also be used in other applications such as Visual Studio Code and also in the different applications in NRF Connect for desktop. So now you are in this program step, and here you can select some different options. So start prototyping, that's actually the out-of-box firmware, so hello NRF Cloud. But if you just want to use regular 80 commands to test different things, you can select this option. Or if you want to directly communicate with NRF Cloud to test out the onboarding process, photo updates, locations, different cool services we have on NRF Cloud, you have this option here. And shell command line interface gives you basically a command line interface towards the device, so you can do more testing through command line, testing throughput, connectivity, and more. So for the purpose of this video, I will just select the same application. So it now flashes the application towards the device. And here you can also click on the link here and you will get up the web page of the documentation on how to use this firmware. So now the program has been successfully flashed to the device. Next step is that it verifies that it's okay. So it reads out some inputs from the device. And the next thing is actually around the SIM card. So here we can see some information about the Onomondo SIM, that you have some free data, same with the wireless logic, and you can also check the coverage in your area. And you can also register ownership to get some additional data for your SIM card, as well to try out some features from Onomondo or wireless logic, for example. And the next step is to evaluate and start prototyping. So since I selected the prototyping application, you get this web interface that I showed in the demo. And also you also have the serial terminal, so you can read out some information, debug information from the device. And the next steps is pointing you towards the Developer Academy, to the interactive online learning platform, as well as guiding you to this best practices for cellular IoT development white paper. And at the end here, you can set up your SDK. So the whole software environment, so you can select the Visual Studio Code and install everything. I'm going to skip that as I've already done that. And here you also have the selections on the apps you can install on NRF Connect for desktop. So when you have run through this, you should hopefully have a better idea what's to do next. And you can also give feedback if you have any improvements, ideas for this process. Let's take a look at the hardware features of the Thingy:91X. So the board consists of two sides, and on the top side, let's take a look at the red squares here. Those are Ignine antennas, and on this new revision compared to the old Thingy:91, we have separated the GNSS and LTE-M NB-IoT into two antennas, and that has proven to be very efficient with regards to the quality of the communication, and that also will give you lower power, because if you are in a good environment with a good antenna, the 9151 does not need to increase the output power. But if you are in a good environment but have a bad antenna, the 9151 needs to compensate and have to increase the output power, and therefore also using more power consumption. So having a good antenna design on your end devices is crucial for low power communication, especially when you are doing anything wireless. So that's a really good achievement on this new board, much better antenna efficiency. And we also have a antenna for 2.4 gigahertz and 5 gigahertz, so basically for Wi-Fi and Bluetooth Low Energy. And also this RGB LED you can configure. You also have a configurable button. You have a separate program debug connector, which you can connect a J-Link device to. And also on the top side here, you can see a solder point if you want to solder on a eSIM, embedded SIM on the side of the device. And here you see the regular SIM socket. And when we are talking about SIMs, you have the opportunity to run software-based SIMs on the 9151. So that's running only code on the device itself, so no external components. And we have different solutions there with partners such as Onomondo, and also you have support for this integrated software SIM solution from NewSIM, supported on the 9151. On the back side of the PCB, we can see the pressure, humidity, temperature, and gas sensor located here, as well as some PMICs driving different sensors, but also this NPM 1300 PMIC, which is responsible for the battery charging of the device, as well as accurate fuel gauging, so giving you an accurate percentage of the life left of the battery. And in the middle here, you have the 5340 SoC and the expansion board connector, as well as the stemma, cubic, groove connector here. So you have a lot of connectors and opportunities with this board, and hopefully we strike a good balance between flexibility for the users on their prototyping adventures. And here you see the USB-C connector as well, so we have upgraded that as well. We don't have the micro USB anymore. But let's talk about the main brain of the Thingnite-1X, which is the nRF9151 system in package Cellular module. And in this system in package, everything has been made by Nordic and built from the ground up to be low power. So inside here we have our own PMIC, we have a separate application processor, and also a separate modem, which everything made by us, as well as the RF frontend. So that's to ensure we have full control to give low power and the flexibility to add new features as we see fit. So we have added a lot of advanced power saving features in our modem firmware, for example, as well as supporting security systems such as ARM Trust Zone and CryptoCell on the application processor. This also gives us the opportunity to do stuff like software-based SIM cards, where we run everything in the secure zone of the application processor. We of course also support standard peripherals such as SPI, UART, I2C, and a 12-bit ADC. And on the modem side, we support LTE-M, NB-IoT, GNSS and NR+, and also NTN, non-terrestrial networks. That's going to be supported later. So that means you can have the device 9151 talking to satellites. So for the application, you have actually a dedicated flash and RAM, so you can utilize that for your applications. Now, let's compare the old Thingnite-1 versus the new Thingnite-1X. What's new? So the old Thingnite-1 was using two antennas, separate antenna for cellular and Bluetooth, but the cellular antenna also combined GPS. And we saw that the performance of that implementation was not super compared to this new implementation we have done, and also it uses much older hardware. We launched the device in 2019, and Thingnite-1X was launched late last year. So there's a couple of years of improvements with new hardware and stuff we have implemented into the Thingnite-1X. As said, we have 3 antennas now, all from Ignion, which basically means we have improved the efficiency on average around 100% on the cellular bands. So if you have tried the old device and saw poor communication performance, you would see a much better performance on this new device, also improving the power consumption of the device. Also, the GPS efficiency has been improved from the antenna side by around 75%. That also means you will get a faster time to first fix with the GPS, etc. We also added Wi-Fi location on this new device with the NRF 7002 Wi-Fi companion chip, improved the out-of-box experience. We had added a lot of expansion possibilities and new and more sensors, as well as battery charging and fuel gauging with our NPM 1300 PMIC. And I would say also a much better integration with our SDK and tools and cloud with this device. So over to the software ecosystem. What do you use to make your applications on this device? So we have the NRF Connect SDK. That's our easy to use, unified and scalable software development kit, which is optimized for Nordic SIP modules, and will provide you bare-like metal performance, power consumption, and memory footprint. We also have proven interoperability, as we have qualified and certified our Cellular stacks, the modem firmware. We certify against all the big telcos, and we also provide extensive out-of-box functionality. So we have reusable Zephyr inherited and Nordic developed software components, as well as production-ready quality. So we have hundreds of NRF Connect SDK-based products in the market already. So how is this built up, and how can you use it? So the reason for us to deliver you this free SDK is we want you to get fast time to market. So we have provided reference application code for both asset tracking, smart metering type cases, and also industrial remote sensors. So you can reuse our software resources and samples and libraries for your custom applications. We also have ready to use 80 command 0 LTE modem drivers, meaning you can select our device and use it as a modem only if you want to. So you can have a big host MCU if you want to have that, and just communicate with 80 commands to our device, acting just as a modem and communicating with the cloud. We also improved, we also have easy integration with the SDK, meaning we have full support of all types of protocols, CoAP, MQTT, HTTP. We have NRF Cloud out-of-box integration with firmware over-the-air support, simple modem APIs for application and modem and interactions, and of course advanced debugging. So when you develop, you want to debug. So we have extensive logging and debugging options in the application firmware, as well as Wireshark integration for modem tracing. So you can look directly into what is happening in the modem, what is sent out and received. So there's no more guessing, you can have everything at your fingertips. So yeah, I've already demonstrated a quick start. That's a tool we have for getting started with our devices. And the next tool we have in NRF Connect for desktop is this Cellular monitor. And this is the tool we provide for modem tracing debugging. So you can directly in Cellular monitor evaluate the network communication and then analyze the modem traces that you capture from your device, either a thingy or your custom device during development. So you can easily check valid network parameters through this tool, but we also have added on this Wireshark integration, which gives you a much broader logging opportunity. You can see exactly what's happening in the modem, and you can also, if you use a sec tag, you can decrypt TLS and DTLS communication with this tool. And we also have serial terminal integration built in, so we can also read the serial terminal, and we also have inbuilt pre-compiled programs in the Cellular monitor if you want to flash some different test applications. So I think this Wireshark integration is super helpful for not needing to guess what is happening to your device. So if you are doing measurements on your device and you see a spike and you have no idea what's happening there, you can do a modem trace and check exactly what is happening. And that moves us over to the power consumption tools. We have the Power Profiler Kit 2, which you can use to measure all of your embedded devices. And we have this tool in NRF Connect for desktop, which give you this waveform, provides you the average current consumption, etc. So you can do average, accurate power measurements, and then fine-tune your application based on this measurement. So all this to make your lives easier and your development faster. And then over to the last part here, we provide everything online for free. So with regards to these hardware files, so you can just copy and paste what we have done on the Thingy:91X. And the hardware files include the schematics, production files, bill of materials, the casings, etc. And that's found on the Thingy:91X landing page. And also on the firmware side, we have based basically all of our learnings throughout the years now on asset tracking applications and developed these asset tracker templates. So typically for use cases with the Thingy:91X, you want to make an asset tracker application, we strongly recommend to check out this template and use that as a reference firmware, because this one has been optimized for asset tracking and also for low power. It also provides a state machine framework, message-based communication using CBus, and a more modular architecture. So It's also customizable and extendable, and it's found on our GitHub link there. So that was all for this webinar. As you can see, the middle here, we have a thingy. This is a picture of the old one, but we provide certified reference design to give you a fast time to market with our complete solution. So this is the whole deliverance from Nordic with regards to cellular IoT. We have the SIP modules. We also provide the mature and globally certified stacks. And in the middle here, you can see also the hardware, the reference design. We have partners, we have the SDK, we have the cloud integration, and of course we have the world-class support. So that was all for this webinar. If you want to sign up for other webinars, go to webinars.com, nordicsemi.com. You can also learn about our interactive online courses at academy.nordicsemi.com. Get tech support help on devzone.nordicsemi.com, or find out more about our products on nordicsemi.com. So now it's time to go to the Q&A section. So any questions you have, I can try to answer them now. Good. So let's start with some questions. And here we have a question. Is it supporting only CAT-M or other technologies as well? Are there other products that support another category? So the 9151 supports LTE-M and NB-IoT, as well as the non-cellular technology called DECT NR+. So you can either run the cellular stack on the modem or this DECT NR+ stack on the modem. So we focus on the low power categories, so that's why we only support LTE-M and NB-IoT on our devices. Another question here, how to set up eDRX and PSM in the board? Is there an application sample that is configurable, such as the UDP sample in the 9151DK? So this out-of-box firmware, which is available as a default, uses actually eDRX and PSM. So that's configurable using the project configuration file in that sample. But you can also use the asset tracker template, as that is also a good starting point for such use case. So that's what I would suggest for you. And here's another question. Is it possible to use the GPS receiver without dropping the LTE-M connection? So you cannot use the GPS concurrently with the LTE-M, but you can use the GPS in the middle. So what I mean by that is either you can use the GPS when the modem is in power saving mode, or when it's in these eDRX intervals. So in between, you can do this GPS fixes. So if you have a eDRX interval of 5 seconds, you should be able to receive a GPS fix between there. And the next question, is both the I2C and the SPI bus available on the expansion connectors? So according to the documentation, only I2C is available on the expansion connectors. And another question, can a Wi-Fi chip be used for bi-directional data connection, or is it only for positioning purposes? So as we have the NRF 7002 on this board, it can actually be used for bi-directional data as well. However, the 5340 needs to be hosted for that purpose. But the main purpose, using the default sample, it's focusing on positioning, but it can be used for more. And here's another question around how to change the APN by software when working with different MVNOs. So you can either use this AT command. I'll copy it and put it in the chat. And another option is to change this directly in the project configuration file. So you have two options: either send the AT command to the device or put this in the configuration file of your application, and you should be good to go. And this is a question about the charge LED, if that's fully programmable. And unfortunately, according to the documentation at least, it's not programmable. It's listed as LED 3 in the documentation. I can also post a link in the chat for that documentation, so you can check that out. Yeah, so only LED 1 and LED 2 is programmable. And here's another question: is the typical power consumption the same as for the old Thingy 91? So no, it's not. We have optimized the application and also the hardware of the Thingy 91X, so it should perform much better than what you were used to on the Thingy 91. As the out-of-box firmware on the Thingy 91, the old one, was more focused as a demonstration, while this new one we have on the Thingy 91X is more optimized and can also be a good reference for and starting point for making a power optimized device. So you should be able to have a much longer battery life with this device. Here is another question: is there a way to set up an LTE-M NB-IoT application that sends periodically data from one of the sensors to our remote UDP server using EDRX and PSM? Yes, that's definitely possible. You could probably use the out-of-box firmware as a reference and combine that with the UDP sample. Then you get both. But for more details on how you could do this, I would suggest to go on DevZone. And here's another question: is there a difference of power consumption between eSIMs and software SIMs? And what we have seen, at least for software SIMs, that they are usually quite good in these EDRX intervals, because usually that's where the external SIMs use some idle current. So if you have an application that uses a lot of EDRX intervals, it could be interesting to use software-based SIM cards instead. So that's something to be aware of. So here's a question about the voice over IP. That's not something we support on this device, so that's not possible. However, it could probably be possible to do something like not on a Thingy, since we don't have a microphone on it, but maybe an expansion board could work. But maybe a push-to-talk type of application could be possible, but need some configurations at least. Regarding SIMs, do they work in Japan? That's a good question. I would need to check the coverage links on that. So I will try to send you the link in the chat after this webinar for that. How can I configure MQTT is another question. So we have a sample in our SDK that is called MQTT client, I think. So that can be used as reference. So then you can set up MQTT-based applications. So here's another question around DECT NR Plus. So this is more of a status on NR Plus. I think that's better to go to your sales representative to ask that, and that's listed on our web page. So you can ask there, and he will help you out, or she. Can you give me some details about the memory? Yes. It's an external memory on the card. Let me check. It's 256 megabits of external flash memory. Yes, so you should be good with that for your applications. Is LTE-M supported in USA? Yes, definitely. LTE-M support is very good actually in USA. So yeah, that's perfectly suitable for applications in US. And there's another question. If I put the eSIM on board, will it require any additional actions to make it work? Yeah, good question. I think you may need to do AT command or something. We have this most likely listed in our documentation, so I suggest you to check the documentation for that specific use case, or go on DevZone to ask there, because yeah, I don't remember out of my memory. And then last question. Using only AT command application from NRF for desktop, what commands should I use to test UDP connections and MQTT? So what you would do here is to open Quick Start and flash the AT command application first off, so you have that on the device. And I will send you the link to the documentations for the serial LTE modem commands for setting this up. Serial. Yeah, so you are talking about UDP and then MQTT. So I assume you are talking about two different use cases, as MQTT is TCP based and not UDP based. So you need to switch between that. But at least in the chat here, I put up the UDP commands, and I'll also put in the link for the MQTT commands. Perfect. So that was all. Yeah, so there's one last question there. I just answered that before we shut down here. What is the use of the serial LTE modem application? Very good question. So this is an application that basically makes the 9151 on the device acts as a modem only. So basically it needs a host application or a PC to send AT commands, and it will interact just as a modem only using AT commands. So that was all the questions. Thank you very much for following along this webinar. Hope you have a nice day, and see you next time. Bye-bye.